Okay, so we're going to start today looking at two different lessons, one today, one tomorrow, on how to compare populations. And a population is just the big group of numbers. And so there is going to be a couple of ways that we can visually compare populations. The first way is called a double box plot. A double box plot is two box plots graphed on the same number line, one on top of each other. And so once you get this down, the best thing that I would suggest is look at page 2 of this notes paper, and you'll see what when we get to the examples, look at the examples, and you'll be able to see what a double box plot is. It's just two box plots stacked on top of each other using the same number line. So that's what that is. If you want to draw an example, you can, but you'll be able to see them once we get to our example problems here in a couple of minutes. So if you need to pause and get this down, you can. Couple other words that you are going to see, and the second one, the interquartile range, or IQR, that is what you are going to use a lot today. The mean absolute deviation. So to deviate means to go away from. So we've got the mean, or the measure of center, add everything up, divide by how many numbers there are. The mean absolute deviation would be how far each data point is from the mean. So for example, if we have a data set right here, a group of numbers, so pretend this is a group of numbers, the mean should be right around the middle, okay? And then we've got different numbers here. The mean absolute deviation is how far away are each of these from the middle, from the mean. So how far away are each separate number from what's in the middle, which is technically the mean. Okay, the IQR, the entire interquartile range, is a measure of spread or variation. The measure of variation tells us how far apart the numbers are spread out. So if we have a big IQR, the IQR is just a number as well. So it'll be a number like 12 or 20 or 6. The bigger the number is, the bigger the IQR is, the more spread out the data is. The smaller the IQR is, the closer together the points are. And so it doesn't really matter which one it is. We don't want one other versus the other. But this is just a good idea. We talked about measures of center yesterday with mean, median, and mode. Where's the middle of the data set? And then the IQR tells us how far apart they're spread out. So a little bit more with the IQR because we are going to be using it today. So first of all, I want to make sure you get this down. IQR is Q3 minus Q1. And I'm going to show you what that means. Okay, so Q3 minus Q1. And you also will probably want to copy down, if you haven't already, this box plot and then label it, because this is what we're going to be labeling. Okay, so the IQR is Q3 minus Q1. So for this example right here, at 0, that is the smallest data point. The smallest data point, which means 30 is the biggest data point. So that line, those lines are going to be stretched out from the smallest to the biggest. This box right here, so this box right here, this box tells us where most of the numbers are. So what this means is most of the numbers are from 15 to 25. There's one that's 0, there's one that's 30. There's going to be a few in between there, but most of the data is in between 15 and 25. Q1 is the start of the box, and Q3 is the end of the box. So then the line that's in the middle of the box, that is the median. So we've got the box where most of the data points are. The median is right in the middle. Q3 is the biggest number in the box, and Q1 is the smallest number. So in this example, Q3 minus Q1 would be 25 minus 15. So the IQR would be 10. That means that most of the data points, most of the numbers in this set are within 10 numbers of each other. That's what that means. Okay, so we're going to be using this IQR to see how far apart they're spread out. So if we've got a box that's really, really long, these numbers are pretty spread out. If we've got a box that's really close together and it's small and compact, these numbers are really close together. Okay, so that's how we would find the IQR. A few other things about using this. So when comparing populations and we use a double box plot, we're going to use the median as the measure of center. So if it says what is the measure of center, use the median. The median is found by the middle line in the box. The IQR would be the measure of variation. So that's what we're using for those two. Okay, remember the measure of center tells us where the middle or the center of this data is located. The measure of variation tells us how far apart they're spread out, how spread out the data is. Usually the closer together the data is, the better that is. That means all the numbers are easily used. Okay, so once you've got that down, let's look at our first example. So it shows us a double box plot there. It says Casey surveyed a different group of students in her science and math classes. And this double box plot shows the results. And notice the question that she asked is listed up here at the top. How many times have you posted a blog this month? We're going to compare their centers and variations and then write an inference that we can draw. So the first thing we'll do is compare the centers. So the median is the center. Okay, so let's find the median of the math class first. Well, that is done by just looking at the middle line of the box. So we've got math class, the middle line of the box is at 10. And so 10 would be the median for math. What would be the median for science? Well, that would be right here, which is 20. Okay. And then to find the variations, we would find the IQR. Okay, so for that would be Q3 20 minus Q1, which is at 5. So 20 minus 5 would be 15. For science, we're going to take Q3, which is at 25, and Q1, which is at 15. So 25 minus 15, and that equals 10. So we're basically seeing how many numbers are in that box. Math class goes from 5 to 20. That's what the box goes from. The science class goes from 15 to 25. So those are the two numbers we're subtracting. Okay. And then write an inference you can draw about the two populations. What I would say is look at where the science class box is versus the math class. The science classes box is a little bit higher than the math classes box. And that shows in the median, which is 20, and the IQR because science is smaller, which means their box is smaller, which means all the numbers are closer together. So an inference we could draw would be science class makes more blog posts. The reason why I say that is because most of their numbers are from 15 to 25. Most of math numbers are between 5 and 20. And so math does not make as many blog posts as science does. Okay, so let's look at another one together. Hopefully it's a little bit easier once we've done a couple together. So the double box plot shows the daily participants for two zipline companies for 1 month. Compare the centers and variations for the two populations. So we'll do compare the centers. So let's compare the medians. I'll do it right here. So the median for Treetop Tours is going to be the middle line of the box, which is 70, okay? So you see where 70 is in Treetop Tours, the middle line of the box. So let's look at Zip Adventures. Find the middle line of that box, and notice that that is at 50, okay? So already we see Treetop Tours a little bit higher up than Zip Adventures. Okay, we'll do the IQR down here. That's going to be the measure of variation. The IQR, we find treetop tours by subtracting the number at the end of the box, which is Q3, minus the number at the beginning, which is Q1. So where does treetop tours box end? The box ends at 80. We're going to subtract 50 from that because that's where their box begins. 80 minus 50 would give us 30. And then Zip Adventures, look at their box. Their box goes from 40 to 60. So Q3 would be 60 minus Q1 would be 40. And 60 minus 40 is 20. So Zip Adventures is a little bit closer together, even though their median is not as big. The center of their data set is not as far up. Their numbers are closer together. And so let's answer that last question. Which company has the greater number of daily participants? Look at the box, okay? Whose box, remember the box is where most of the numbers are. Whose box is higher up on that number line? Will be Treetop Tours. So I would say on average, Treetop Tours has the greater number of participants. Okay, before we move on from that, I do want to show you one more thing. And if you look at this box, the double box plot there, what's something you notice that we haven't talked about yet? You see something? Do you see this star right here? The star right here? Okay, that star is away from everything else. Okay, but it's still on that double box plot. What that star is that would be an outlier. So if you want to label that, sometimes you're going to see those stars. So that means all of the numbers for Treetop Tours are right around 50 to 80. Sometimes they're a little bit greater than 100. Then we've got this outlier that's all the way over to basically 130. It's way far away from everything else in the data set. It still needs to be included in the double box plot, but we're not going to attach it because it's by itself. It's way out there. Remember what we talked about yesterday with outliers? They're far away. They don't do a whole lot when we talk about the measure of center. And so we have to write it there, but that doesn't have anything to do with the median or the IQR. So that would be the outlier that's right there. Okay, so the last one I want you to try on your own. Answer those 2 questions that they ask you to do about this double box plot. Okay, so first thing we'll do is compare the centers and variations. So the median is the measure of center. And for Hayes Road, the median is at 55 miles per hour because that is where the middle line of the box is. And then for Jefferson Road, the middle line of the box is at 45. Okay. So then we've got the IQR, which is the measure of center. For Hayes, we need to subtract the Q3 and Q1. Q3 is at 60, Q1 is at 50, so 60 minus 50 would be 10. That's pretty close together. If we just got 10, that's pretty close together. And then Jefferson Road, Q3 is at 55 and Q1 is at 40. So subtract those two. 55 minus 40, which is 15. Okay, so Hayes Road is a little bit closer together. It's not as spread out and it's higher up. And then Jefferson Road is a little bit more spread out and cars are tending to go a little bit slower on that road. Okay, on which road are the speeds greater? Now, I want you to see the outlier, Jefferson Road, somebody is, they're speeding like crazy. They got somewhere to be. They're at 78. But remember, does the outlier really affect the rest of the data set? We don't want to really focus on that. So we're going to focus on where is the box. To answer the last question, where is the box at? Well, Hayes Road is up around 55. Jefferson Road is right around 45 or 50. So on which you would say Hayes Road for this one? So if they ask that question, which one is greater, forget about the outlier. You focus on where the boxes are. because that's where most of the numbers are going to be located. So Hayes Road would be greater speeds because most of their numbers are higher up than Jefferson. Okay, so that is comparing two different populations using a double box plot. And so you can do some of those these questions that are listed here and get some more practice with this.